Welcome to the Business Process Modeling tutorial. This tutorial lesson provides an overview of the business process modeling notation using the Visible Analyst. After explaining the use of the symbols and lines used to model BPMN diagrams, we will create a sample BPMN diagram based on some of the business processes performed by a Department of Motor Vehicles. We will access the repository entries created in the Visible Analyst to further define and explain these entries. Because the BPMN model information is meant to be distributed to the interested parties, commonly referred to as stakeholders, the printing and reporting capabilities of the Visible Analyst are reviewed in this tutorial lesson. Note that some of the terminology used in BPMN has the same name as other modeling objects, but a different meaning when used in BPMN. We will point out the differences in meaning when appropriate. The Visible Analyst support for the business process modeling notation diagrams is based on the Business Process Modeling Initiative, developed by the Object Management Group. The complete specification is available for download from the OMG website. The primary goal of BPMN is to provide a modeling notation that is an effective communication medium across all the constituencies in computing technology-supported organizations. Prior business modeling notations, such as workflow diagrams, data flow diagrams, or activity diagrams, were used by the business users to generate their models. While the users were comfortable with these diagrams, there was a disconnect with the languages that were written to execute the processes. The BPMN methodology and notation has been developed by OMG to provide a mechanism for not only developing the models, but using these models as the basis for generating XML execution language. BPMN is specifically designed to communicate process behavior information in a manner easily understood by business end users, while also providing supporting technology organizations with sufficient information about process execution, flow, and dependencies to understand the workings of the business processes being modeled. The BPMN notation is designed, therefore, to support the needs of not only business end users, but also the business analysts who develop models and technical analysts who implement the models. BPMN models describe the business process behavior and, as a result, use an event-based paradigm. Both parallel and conditional behavior is supported by the Visible Analyst's implementation of BPMN. It should be emphasized that one of the drivers for the development of BPMN is to create a simple mechanism for creating business process models, while at the same time being able to handle the complexity inherent to business processes. BPMN was developed to provide businesses with the capability of understanding their internal business procedures in a graphical notation, and will give organizations the ability to communicate these procedures in a standard manner. As with similar methodologies in their early development, the standardization provided by BPMN provides organizations, and you, the individual tasked with developing the BPMN models, the ability to communicate these business processes. Let's review the basics of BPMN modeling. There are three BPMN model types that may be used within an end-to-end BPMN model. Private, internal business processes. Abstract, public business processes. Collaboration, global business processes. The first BPM model type is used to model private or internal business processes. These are private business processes that are internal to an organization, such as the licensing section of a Department of Motor Vehicles. If swim lanes are used, then a private business process will be contained within a single pool, with all sequence flows contained within the pool and no message flows crossing the boundaries of the pool. Message flows can cross the pool boundary. The second BPMN model type is used to model abstract or public processes. These are processes that represent the interactions between a private business process and another process or participant. Only those activities that are used to communicate outside the private business process, plus the appropriate flow control mechanisms, are included in the abstract process. The internal activities of the private business process are not shown in the abstract process. Thus, the abstract process shows to the outside world the sequence of messages that are required to interact with the business process. An example of this model is the interaction between the driver applicant and the Department of Motor Vehicles. The last type of BPMN model is the collaboration or global process. A collaboration process depicts the interactions between two or more business entities and is defined as a sequence of activities that represent the message exchange patterns between the entities involved. A collaboration process can be shown as two or more abstract processes communicating with each other. The appointment cycle interaction performed by a driver applicant and a Department of Motor Vehicles is an example of a collaboration process. There are four basic categories of BPMN elements used to create the BPMN models, which allow the viewer to easily differentiate between sections of the BPM diagrams. Flow objects, which consist of event symbols, activity or process symbols, and gateway symbols. Connecting objects, such as sequence flows, message flows, association flows, notes link. Swim lanes or pools are used to represent participants of a process. The lanes within a pool are used to categorize the activities in a pool. Artifacts are used to provide additional information about the process. Flow objects are the main graphical elements of the diagram and consist of the event, activity or process, and gateway symbols. An event symbol is used to indicate something that occurs during the course of a business process and which affects the flow of the process. There are three types of events: start events, intermediate events, and end events. Each event type may have a trigger, that is, a determination for the cause of the event. Each event trigger has a unique appearance to indicate the trigger type. When the trigger is a message, an envelope icon is added to the event symbol. When the trigger is a timer, a clock icon is added to the event symbol. This picture displays examples of the various event symbols. Notice that not all trigger types are available for all events. For example, an end event cannot be of type message. The start event symbol is drawn using a single thin line and may contain a trigger icon. An intermediate symbol is drawn using a double line and may contain a trigger symbol. The end event symbol is drawn using a bolded line and may contain a trigger icon. The activity or process is a generic term that represents the work that a company or organization performs. Activities can be atomic or non-atomic, that is, compound activities, and are represented as a rounded rectangle. Activity types include process, subprocess, which can be defined as a transaction, and a task. When a process has been exploded in the visible analyst to show the sub-processes, The embedded or nested subprocesses are modeled and displayed on a subset or child diagram. A process that has been exploded has a plus sign marker added within the process symbol to indicate that the process has been decomposed. There are 5 markers used within the activity symbols to show a collapsed subprocess, a loop process, a multiple instance process, an ad hoc process, and a compensation process. A gateway is used to control the divergence and convergence of multiple sequence flows. It will determine branching, forking, merging, and joining of paths. Gateways are represented as a diamond symbol and may contain an icon indicating the gateway type. The gateway, also sometimes called a fork in the road, is used to indicate decisions, where the sequence flow can take 2 or more alternate paths. For a given performance or instance, only one of the paths can be taken. A decision is not an activity from the business perspective, but is a type of gateway that controls the sequence flow between activities. It can be thought of as a question that is asked at that point in the process, and the question has a defined set of alternative answers referred to as the gates. Each decision gate is associated with a condition expression found within an outgoing sequence flow. The conditions are evaluated in a specific order, and the first condition that evaluates to true determines the sequence flow that will be taken. One of the gates may be marked as default and is the last gate considered. Choosing a particular gate chooses the corresponding sequence flow. An exclusive decision, gateway XOR, has 2 or more outgoing sequences, but only one of them may be taken. The conditions exiting the gateway are evaluated in a specific order, and the first condition that evaluates to true determines the sequence flow that will be taken. One of the gates may be marked as default and is the last gate considered. Exclusive gateways can be used as a merge or as an alternative sequence flow, though rarely used in this way. There are 2 types of exclusive decisions: data-based and event-based. A data-based gateway does not contain an icon, while an event-based gateway has a star icon surrounded by a double circle. The data-based exclusive gateways are the most commonly used type of gateway. The inclusive gateway OR can be used to model inclusive decisions, or it can be used as a merge. It represents a branching point where alternatives are based on the conditional expressions contained within an outgoing sequence flow. The true evaluation of one condition does not exclude the evaluation of other conditional expressions, but one of the conditions must be true. An inclusive decision gateway symbol has a bolded circle within the diamond gateway symbol. When used to model inclusive decisions, each of the sequence flows, and there should be at least 2, would be attached to the gates of the gateway. The condition type of the sequence flow is set to expression, and you would add the expression to be evaluated in the condition expression field of the flow. A default sequence flow may be used. When the inclusive gateway is used as a merge, it will wait for and synchronize all tokens that have been produced upstream in the model. It does not require that all incoming sequence flow produce a token, as the parallel gateway does. It does not require that all incoming sequence flows produce a token, but it does require all of the sequence flows were actually produced upstream by an inclusive OR situation, for example. If an upstream inclusive OR produces 2 out of a possible 3 tokens, then the downstream inclusive OR will synchronize those 2 tokens and not wait for another token, even though there are 3 incoming sequence flows. Note, a token is a descriptive construct used to describe how the flow of a process will proceed at runtime. A token may have a unique identity to identify the tokens, since tokens can be split to model concurrent or parallel processing. Complex gateways are included to handle situations that are not easily handled through the other types of gateways. Complex gateways can also be used to combine a set of linked simple gateways into a single, more compact situation. Modelers can provide complex expressions that determine the merging or splitting behavior of the gateway. The symbol for a complex gateway contains the asterisk symbol within the gateway diamond symbol. When the gateway is used as a decision, then the expression determines which of the outgoing sequence flow will be chosen for the process to continue. The expression may refer to process data and the status of the incoming sequence flow. For example, the expression may evaluate the process data and then select different sets of outgoing sequence flow based on the results of the evaluation. The expression should be designed so that at least one of the outgoing sequence flows will be chosen. When the gateway is used as a merge, then there will be an expression that will determine which of the incoming sequence flow will be chosen for the process to continue. The expression may refer to process data and the status of the incoming sequence flow. For example, the expression may specify that any 3 out of 5 incoming tokens will continue the process. Another example would be an expression that specifies that a token is required from a sequence flow A and that a token from either sequence flow B or C is acceptable. The expression should be designed so that the process is not stalled at that location. Parallel gateways provide a mechanism to synchronize parallel flow and to create parallel flow. These gateways are not required to create parallel flow, but they can be used to clarify the behavior of complex situations where a string of gateways are used and parallel flow is required. In addition, some modelers may wish to create a best practice where parallel gateways are always used for creating parallel paths. This practice will create an extra modeling element where one is not required, but it will provide a balanced approach where forking and joining elements can be paired up.